Hello lads. So we're going to look at the not all the constructions, but this the most pertinent construction. So the first one we're going to look at is the circumcircle. Okay, so the circle. Okay, and it does what it exactly says in the thing. It's a circumcircle that goes around a triangle. Okay, so in order to do it, what we need to do is to find the perpendicular bisectors. Okay, so let's take those in tandem. Perpendicular means at right angles to the line that you see, and bisector means cuts it in half. Okay, so to find the perpendicular bisector, so I'm just going to stretch it more than where I think half is and just scribe a line, and then without changing the distance, reverse the process. This is not going to be 100% accurate, but it'll be close. Okay, so I'm going to join those two as accurately as I possibly can. And that's a perpendicular bisector. Okay, it's cut the line in half and it's perpendicular to the original line. I'm going to do that in one other location. I need to do it in two locations. So again, stretch it just beyond where you think half is. Scribe a line, reverse the process. Scribe another line where the two of them meet. Join. Okay. I can already see I made a mistake in this one, but this one we'll go with it. So as you can see, this is the point. So it should touch all three. Within the margin of error it does. Okay, now I'm going to do it again, but this time I'm going to do it on a triangle that isn't as right angle-y, because as an angle gets greater, as one of the angles in the triangle gets greater than 90 degrees, you're going to get this possibility where the point you're looking for is actually outside the so I'm going to do it again with a nicer, neater. So you don't plan for these things. Hopefully this one's a bit nicer. So I'll do it again. I'm going to do this a tiny bit quicker. Stretch a bit further than half. Scribe a line. Same on the other side. Scribe a line. Join the two lines. Now I wouldn't recommend using the same pencil, because if you use this pencil it'll move the nib of it and that can cause this to get wobbly. So I'd use a separate pencil to do the other bits of the constructions. So let's do the same here. Scribe a line. Scribe a line, and there those two meet. So there's your two perpendicular bisectors. They meet right there. Let's put it onto an edge and let's just check. And there you have it. Okay, so that's the circumcircle. Now, from a coordinate geometry point of view, you can find the midpoint of that line. If you know those two coordinates, look, x1, y1, x2, y2, you get the midpoint, that'll give you that point. You get the slope, that'll give you the slope of blue, and you can use the fact that the perpendicular slope through that point will give you this equation. So that'll be equation 1 of that perpendicular bisector. Repeat the process, get the midpoint of this line, get the slope of this line, get the perpendicular slope plus that midpoint will give you the equation of this one, and then a simultaneous will give you that point right there. And from that point, you can use that point with the distance from there to give you the radius of the circle, and then that's just either minus g and minus f or h and k along with the radius will give you the equation, the circumcircle. Okay, so that's the circumcircle done. Now the next one is the incircle. The incircle, and again it does exactly what it says on the tin. So I'm going to draw a circle, and the incircle tries to make a circle inside. So in order to do that, we're going to bisect the angles. So the circumcircle bisects the sides, and this one bisects the angles. So again, how to bisect an angle? It's not that hard. Okay, you don't have to make it as light, just make any line and make the same line and where they touch the sides, do it again. And then draw a line along that path. Okay, as accurately as you can. And then repeat the process somewhere else. Okay. Where 2 lines meet. That should be the center of a circle. Nearly perfect. You can be a bit more accurate to me because you're younger and have better equipment, but that's it. There's your circumcircle. That won't be done in the coordinate geometry way because it's, you know, bisecting an angle is a lot harder. Okay, now that's not impossible, but you know, coordinate geometry wise, bisecting an angle is quite a lot harder. You have to use that tan M1 M2 over 1 M1 M2 formula, and that would just be a little bit harder. Okay, so next one is the centroid. Okay, so again, I'm just going to draw a triangle. So centroid's quite easy. It's very similar to the circumcircle in that you find the midpoints, but instead of getting perpendicular bisectors, you just join the midpoints to the other corners. So that's what I'm going to do. I'm just going to stretch it by more than half and work out and what I'm really after. I don't care about the perpendicular bisector, I just want the midpoint. So when I got the midpoint, I'm just going to join it to the other side, to the opposite side's vertex or corner. Okay, and do it somewhere else. So again, all I really care about is the midpoint. Once I have it, join it. Now you can do the third one, but that is the centroid. Okay, so there's the centroid done. I'll do it on the third one just for the fun of it. Okay. There you go, I was close. There's your centroid. Okay, so that's pretty cool. Now the last one is the orthocenter. Okay, so the orthocenter. So again, I'm going to draw a triangle. Now this one's a bit unusual in that you don't have to use the compass for this one. Okay, you actually just use a set square and a ruler. Okay, and the idea is you line it up and you move it so that you get a right angle. And do the same thing somewhere else so that the right angles and there you have it. There's the orthocenter. If you don't believe me, you can do it on the third side. And you'll see that lines up just along. So there's the orthocenter. Now this one can come up in coordinate geometry because if you know x1, y1 and you know x2, y2 and x3, y3, then you can find the slope of this line, which would be perpendicular to the slope of this altitude. Okay, and once you know that, you have this point here, so you can work out the equation of this line, you could work out the equation of this line using a similar method, and you could find that point just using slopes and other equations. But again, you come back, just like with the circle, you come back to using a simultaneous equation on two lines to find the point. Okay, so I hope that gives you a bit of an insight. I hope that helps you out.